Signal Sciences is the industry's first web protection platform that works in any cloud, any container, any platform as a service, and any modern application architecture. The Signal Sciences web protection platform can be deployed in next-generation WAF, RASP, or reverse proxy modes, giving customers ultimate flexibility and coverage. Protect your web applications with Signal Sciences web protection platform. Signal Sciences, protecting applications, connecting teams. For more information, check them out at signalsciences.com/PSW. Layered Insight is the industry's first embedded security approach for containers. Trusted by Global 1000 enterprises to secure their containerized applications, it's the only solution that requires no root privileges, has zero dependency on the underlying infrastructure, and is fully portable across any container environment. Unified DevOps and SecOps, enabling the rapid development of containerized applications without worrying about security. To learn more, please visit layeredinsight.com/ASW.
Welcome back, everyone, to Application Security Weekly. This is the news for week of, that would have been February 25th. So we are going to cover a couple of older articles here. I did want to start, though, with the fact that 7,900 vulnerabilities didn't make it into the CVE database in 2017. So I thought that this was a really interesting article for us to cover, Paul, because of the 18,000 CVE IDs that were assigned or allotted last year in 2017, almost 7,000 of them were in a reserved status, despite over 1,000 of them having a public disclosure being indicated or something that was going to happen. Curious to get your thoughts there, because you've been in the industry for such a long time, Paul, that you've seen the growth of CVE IDs over that kind of period of time. What do you think of the fact that 7,000 are now absent?
If you've spent any time researching or paying attention to the research that surrounds CVE, spoken to people at MITRE, Josh Corman talked about this last year at Source. I've done some research projects in my time about CVE. This is really no surprise. Not every vulnerability gets a CVE. Now, there are some light at the end of the tunnel, but if we just look at the CVE problem, for example, there's lots of stats in that article, but the stat that I like to use based on my own research, like any vulnerability scanner out there, the top ones that have the best CVE coverage, I want to say we're around 40, maybe 50,000 or less. And currently today, if you go to cvedetails.com, there are 97,367 CVEs in the database. And we know from other people doing research that doesn't cover everything. Now, what's interesting is when we talk about finding or discovering vulnerabilities, we can even keep this specific to web applications. We all know that generic tests for a particular vulnerability or exposure or configuration misuse can find vulnerabilities that we don't necessarily have like a straight up CVE for. So that's kind of the light at the end of the tunnel, is you don't necessarily have to have a CVE assigned to a vulnerability in order to discover it in your process. In other words, application scanners, wherever you're doing that scanning, static analysis, dynamic analysis, wherever, or a traditional vulnerability scanner, or something that's looking at your source code repositories and trying to discover vulnerable library versions. That one's tougher. I think it's more specific. They may add checks for things that don't have a CVE. And those are hard to track, because how do you know what they are? Because you don't have a key, right? There's no key for it. So I think that this is, certainly a problem. I don't think it's as big a problem as some might think, because again, we do have the capabilities to detect some of these conditions. They're just not tied back to a CVE. And so some of the kind of when you're evaluating a solution, if you want to look at it that way, a lot of people who use CVE as the evaluation criteria. It's not the best criteria. It is a measure, and you should take that in consideration when you're evaluating. But also you have to consider, like, what if someone has a particular method to discover a vulnerability or exposure that could cover 5,000 CVEs that you just haven't referenced those 5,000 CVEs. So that's, I've actually done some research in this space. It is a little frightening, but not as bad as people think.
And what's interesting to me is for a lot of organizations, as my friend Brian would say, the enterprise will have to standardize on something. And to this end, most of them will say, look, if it has a CVE, We'll look at the CVSS score for it, and then we will address it accordingly. And unfortunately, that's kind of a standardized process for a lot of organizations, especially the bigger ones. At the end of the day, you've got to get the work done somehow. And so I imagine that that is as good as any process to start with. But unfortunately, I think a lot of organizations don't take the approach that you're suggesting here, Paul, which is they don't go a step further to say, look, we can still identify vulnerabilities that maybe don't have a CVE number associated with them, but are still a risk to our organization. What I found especially interesting in this article was in 2017, web-related issues accounted for over 50% of all of the 18,000 vulnerabilities that were disclosed. And 31, or nearly 32% in this case, actually had public exploits. So to me, that just, I think, goes to show not only the reason that the show exists, but the increasing presence of the use of web technologies today in terms of cloud or otherwise that are now being more thoroughly vetted and actually being recognized in the CVE database accordingly. Curious to get your thoughts there, especially given the fact that there were over 50% of those vulnerabilities were web related. Does that surprise you at all, Paul?
No, not at all. You know, I was speaking with Faru Mavatuna from NetSparker actually about this topic, and you know what he said was kind of scary was that some of the ways that we identify vulnerabilities in web applications can be very specific to a version number, right? Or a specific condition in the code that they're testing for that publicized vulnerability. However, as you very well know, and our listeners know, people tend to modify code. You could very well modify a configuration, the code itself, how you interact with that can obscure that vulnerability. So the way you're checking for it's like, oh no, you're okay, unless you have some kind of, in NetSparker's case, they make a dynamic scanner. So Farrow was like, yeah, unless we go test that, and I don't care what version it is, I'm going to test for the vulnerability in the application. And even if you've modified it, I'm going to say you got SQL injection. And you may say, well, you know, I've upgraded that library. It's not vulnerable. Yeah, but you modified it and still made it vulnerable to SQL injection. And you can find that sometimes by actually testing it in practice, that the software that looks at the libraries you're deploying and says, nope, that one's good because you upgraded it. But the dynamic scanner will say it's not good because I tested it and there's still SQL injection in it. So that's some of the, it kind of reinforced for me the importance of still having some kind of dynamic scanner in your SDLC looking at your code. I still think that's important. I think we've talked about that too in terms of functional testing and security testing still being part of that DevOps process.
For sure. And in fact, I mean, there's the opposite problem too, where the scanner is telling you you're vulnerable, but you've updated the library, like the sub library in some sort of subdirectory that is actually where the vulnerability is presented. And just because the version number hasn't changed on your configuration
Correct.
file, it still says you're vulnerable, even though you're not. Mm-hmm. So the only way to really know is to actually test, right?
Yep.
Which is where I think that, tooling can certainly help. Crowdsourced security testing can certainly address that as well. From a, you think you fixed it, but maybe you haven't perspective. I actually wanted to move to our next story, though, Paul, if that's okay with you.
Yeah. You want to do the Trustico?
I do, yes.
Hot mess.
In fact, so I wanted to call out DigiCert put out a statement on what I think most people know by now has been an incredible dumpster fire of certificate authority issues related to Trustico. Basically, Trustico requested a revocation of their semantic geotrust, thought, and rapid SSL certificates, claiming that the certificates were compromised. And then when they were asking for proof from Trustico, Trustico's CEO sent approximately 20,000 certificate private keys to DigiCert, at which point DigiCert had no choice but to actually act in accordance with the CA/browser forum baseline requirement, which mandated that they revoke the compromised certificates within 24 hours. So effectively what happens here is Trustico says, we don't want to have these certs anymore. DigiCert, we want you to revoke them. DigiCert says, we can't unless you've been compromised. And then the CEO says, all right, well, here's 20,000 plus certificates or private keys for certificates for companies that need to be revoked. And DigiCert was like, what? Mm-hmm. So this has broken quite a lot of number of websites out there, Paul. But I'm curious to kind of get your thoughts here, because this sounds like an abuse of the rules on the part of Trustico.
Well, yeah, I think it is too. I also do want to state that DigiCert is actually a sponsor of Paul Security Weekly. Although their advertisements are not running yet, they are very much a sponsor. And so we went out to our contacts. They provided us with this article that you linked to in the show notes, Keith. And so a couple things, right? DigiCert has purchased Symantec's SSL cert certificate authority business. So when they say Symantec certs, that's really a DigiCert controlled certificate. DigiCert did what they had. They were basically forced to revoke these certificates. I think DigiCert, in talking with people about this, DigiCert and likely the other certificate authorities, GeoTrust, Thought, and RapidSSL, acted in accordance with the proper guidelines and had to revoke those certificates. Now, the questions that I have are on the Trustico side. We were speculating last night. So, first of all, how did Trustico have the private keys? Were those leaked to them by the attackers? Did they somehow have access to the private keys without permission to the users? Did they ask permission of the users to do anything that they did? Why didn't they just leave it to the users to tell them, look, your certificate's been compromised, you have to reissue it, and just leave it up to the user? Are they looking out for the best interest of the user or not? Or do they get money by having these users renew or rekey those certificates or issue new certificates? I don't know. I don't know the answers to a lot of those questions, but it does beg a lot of questions.
That last point is actually something that's really interesting as well, because I know that the sale of certificates, depending on the form of certificate itself, has been somewhat brought into question with the rise of Let's Encrypt, right? Like that has taken a lot of the kind of lower level certificate market out from underneath some of these other companies. So yeah, it definitely begs a lot of questions. How they had the keys is something that baffles me currently, but that the CEO just sent them over in an email is mind blowing.
Yeah,
right?
that's just
how.
I don't know what it is.
I wouldn't be surprised if some sort of lawsuit comes forward against Trustico for this, because quite frankly, that's almost like, gosh, I'm trying to think of a good analogy that I could make here, but actively compromising your own keys rather than just confirming that your keys have been compromised seems like such a violation of some sort of law or policy, or at least it's something that will probably be questioned somewhere, I hope.
I want to talk about your story number 3 in there, critical Linux file system permissions. Because I think as it relates to application development, Keith, I really think that it's one of the most common security violations that I see from developers. Anytime I've taken over a project or gotten involved in providing the systems administration for developers, I almost often or always find some like gross violation of file system permissions that could potentially lead to some security incident. And that, of course, stems from a troubleshooting process has taken place. And in that troubleshooting process, Chmod 777, like they need T-shirts that say Chmod 777.
Oh no!
And sometimes that fixes it. So they're like, yes, 777 for everything. But of course, that, especially when we talk about PHP applications, I've seen that a lot. Or just even now with Docker and DevOps, that is now more common. To be included in Docker files and in other things just to like make things work. So I think this is a huge problem. And I think it's something that like DevOps doesn't necessarily solve inherently. Like nothing removes the requirement for understanding proper file system permissions, and developers, I mean, as well as everyone who uses Linux, right, I think are really quick to just change those permissions to be world readable and writable and executable.
And the worst part about this situation, and so this is specifically related to NPM, so the Node Package Manager. As someone wrote on Twitter, and I'm forgetting who it was now, they basically said, look, for the past 20 plus years, we have been trying to convince the world that package managers are safe. And in version 5.7.0 of Node Package Manager, they effectively had a bug where it was traversing and running chown on the wrong and often critical file system
Mm-hmm.
folders simply by running a command like sudo npm --help or sudo npm update -g would cause a file system change of ownership for things like /etc, /user, /boot,
Mm-hmm.
and other critical system directories to be changed ownership to npm rather than to root or others. And so it was just a colossal bug from a Node package manager
And
user,
I've
which,
seen
by the
this a
way,
lot. I've seen this a lot, actually, Keith. And not specifically with Node Package Manager, but other software and packages that you're using, when you apply an update, as part of that update, they have to change file permissions and often do that in an insecure manner. That's something I've seen since like the beginning of time.
yeah, and it's just like for this, I mean, especially if they're doing it badly, right? Like you think about npm and what it's installing. It's installing all of your packages that are actually managing all of your front end web interfaces. So in some cases, it's actually things like your ORM or other sort of things that are working with the database, right? And so you're often running npm to actually deal with a lot of the server side and sometimes even the client side JavaScript presentation layers. And so to that end, to have such a bug where they are doing things badly, where they maybe didn't even like run a test, like you'd think that a unit test or an integration test would be in place here to say, hey, when we're actually traversing these file directories to make sure that we're updating things appropriately for our installation and then maybe returning them to the state that they were in, that this would have been caught. And the fact that it was actually put out in, I wouldn't call it a major release, but it's certainly not a minor release because it 5.7.0 would mean that they kicked it up a notch, right? So, yeah, this is just all bad on a lot of levels. And I
Mm-hmm.
believe it has been fixed since, but to that end, to have just bad file changes take place on something as simple as like a help command, come on, npm, like step up your game.
Mm. What else you
So
want to
Paul,
talk
I actually
about?
wanted to I was going to say, I know that we're a little bit pressed for time. We have about 10 minutes here. I actually wanted to cover something related to code signing certificates, actually. So story number 2 under the if you build it, they will come is related to the fact that Recorded Future, which is a threat intelligence organization out of
Mm-hmm.
Boston,
Mm-hmm.
has cited that the rise of code signing certificate counterfeit instances is taking place at a much larger rate than it used to. And it's interesting to me because the sense that code signing is effectively a hashing of the code that is being released so that you can determine cryptographically that it is in fact being released by the same developer or being released by the same group or organization. It's intended to let you know that the code changes that have taken place were intended, were purposeful, and of course were signed appropriately. And so since 2011, the stolen credentials of code signing certificates has started to take place. I think we saw it with Stuxnet, for example. There was code signing that took place for some of the Microsoft patches that in turn were actually not really released by Microsoft. And there was a third party company that was compromised that the certificate signing was taking place from. But in this case, they've seen this grow significantly through 2015. And to no one's surprised, really. I mean, if you think about it, we're starting to see a world where SSL is, and TLS specifically, is starting to become ubiquitous. HTTPS is being prioritized by things like Google. And to the extent that code signing is so important for developers to validate that the code that they are pulling down from places like GitHub or NPM are real and authentic, this is getting to be more and more of a problem where if you can't actually monitor that the code is good, you could be pulling down bad code. And if I'm actually now taking a situation where I can, create a counterfeit and then say that, yeah, no, this code is good, pull it down, this is going to lead to compromises of organizations at some point, especially when we look at things like NPM. What are your thoughts there, Paul?
I think this is an attack that we're going to see for years to come. I certainly think that it's something we've seen in the past, and we're going to continue to see because it exploits people's trust. And anytime you can exploit people's trust like this, it's going to be something attackers prey on. So it's not surprising.
For sure, and again, as code becomes more ubiquitously available, in the case of like GitHub, I think that yeah, you're right. We're going to definitely start seeing more of this, and I hope that the processes through which code signing is taking place kind of steps up their game cryptographically as well, to prevent the kind of counterfeit certificates that are taking place as we see in this article. Actually wanted to jump to a discussion on a GitHub event that happened recently on Wednesday at about 12:15 Eastern time. GitHub was starting to be hit with 1.35 terabytes or terabits, excuse me, per second traffic as a result of a mem caching problem that was reflecting out to GitHub. I mean, can you imagine the kind of devastation that could take place, Paul, if GitHub was no longer able to serve up content to users that are developers that are actually making use of different code repositories?
Yeah, that would be bad.
Yeah.
That would
Thankfully,
be bad.
Akamai, I was going to say Akamai stepped up and started covering this as probably through services that GitHub has purchased. So about 10 minutes after the DDoS started, it actually was basically mitigated and brought down. But the fact that someone can, without the use of a botnet, use memcache servers that exist out on the internet to serve up content and reflectively attack based on spoofing the source out to places like GitHub at 1.35 terabits per second. I don't know very many organizations that can withstand that kind of firepower. And I assume that what will happen as a result of this is this was a test and companies will be held ransom for DDoS with this sort of attack. And quite frankly, as of apparently Shodan, there's about 100,000 memcache servers that reflect out at about 50 times the request back to the spoofed IP address. So 1 kilobyte becomes 50 kilobytes effectively for each one of those. So this is just all bad.
It is bad.
And so, Paul, I know that for the food for thought section, just jumping into that because we have a few minutes left here, you wanted to talk about this light phone. Tell me more about this.
Yeah, so this came up in some of my news feeds, and it's actually the second version of the light phone. So the original light phone could just make calls. This one allows you to call and text. It's essentially a phone that's 6.5 millimeters thick and the same length and width as a credit card. So that's pretty cool. So my kind of like use case for this was like maybe you'd take this like when you travel or specifically if you're going to a security conference, you don't want to take your phone with all of your apps on it and stuff. You could take one of these. Where my kind of use case falls down is like, what if you're traveling and you need to call for an Uber? I don't.
Right.
Can you do that with just calls and text? Like, I'm pretty sure you need the app. I don't think that there's phones at Uber to call up and say, hey, can you send me an Uber? Pretty sure. Correct me if I'm wrong, audience, but I'm pretty sure that you need the app for that. So I guess that'd be one of my feature requests. I would like to use this for travel because it's small, it's light. I don't have to put all my applications on it with all of my two-factor and passwords and credentials, like on my phone today, right? There's LastPass, social media, all of the apps to control all of my smart devices and home devices. My email and Google account is on there. Like there's a lot of stuff on my phone that I don't necessarily need to take with me all the time, except for those like convenience type features. Open Table is another one that comes to mind. Like, especially if I'm out and about, like the apps that I truly need to use, I mean, unless I'm posting pictures of my food on social media, are Open Table to make or check reservations, and Uber to get from point A to point B. So.
Yeah, and to that end, unless you're in a city that is known for its taxi service like London, I can only imagine that not having your Uber or Lyft app is going to be a cause for real problems for you.
Yeah.
I did want to cover one or actually two more articles specifically. Story number one under the food for thought section I thought was really interesting. We don't have to go too deep into it, but Mark Cuban, who's a somewhat famous investor, basically was saying that as a result of artificial intelligence and the growth and adaptation of artificial intelligence over the next 10 or 15 years is actually going to make majors like philosophy or psychology more valuable than computer science because effectively the machines will start coding themselves. Really curious to get your thoughts there, Paul, especially because you've seen this industry change over time. As have I, when going from a 28.8 dial-up when I was a kid to now where I'm doing video streaming, podcasting, right? To that end, I'm not sure he's wrong, but I'd be really interested to get your thoughts.
That makes me older than you because I started out with a 14.4 modem.
Well, thankfully, as they say, I'm trying to remember, the curve, exponential curve over time of growth of technology. You can't be that much older than me.
That's true. That's true. That's true. I think it's interesting to speculate that computers will write all the code themselves. Although, I mean, given that humans will be coding the algorithms for computers to write code, there'll still be issues. So I don't think it really solves
For sure.
our security problems. I think it's an interesting observation from Mark Cuban. I don't think it's a game changer, and probably a long ways away, and we'll never truly know until we get there.
For sure. I think that it will probably creep up on us more than anything, but I would be very interested to see what the world looks like based on kind of what he sees as the future of, people that can ask the right questions of the computer rather than people that can actually code it themselves, and how that will affect society overall, which it might not be necessarily a bad thing if we have more philosophical thinkers in the world than people that just sit in a closet and write code all day.
Yeah.
So the last one that I wanted to end on, though, today, Paul, was something here called How to Suck at Information Security. It is a PDF by Lenny Zeltzer, so SANS Internet Storm Center handler, that put this out. I thought it was a great checklist of, if your organization is doing the things on this list, you're doing security badly. And rather than taking the top 20 list of security controls or things you should be doing, it highlights the things that mean that you're not doing security very well. One of the ones that I really enjoyed was the security practices section on the bottom middle that says, you can suck at information security if you say no whenever asked to approve a request.
Yep.
Did you have any favorites, Paul?
I liked deploy a security product out of the box without tuning it.
Yeah.
That's a pretty good one.
Or in the same section under security tools, buy an expensive product when a simple and cheap fix may address 80% of the problem.
Mm-hmm.
Cheap and or free, as you will find out at InfoSec World at Pulse Talk.
Yes.
So
yes.
It is a rather funny PDF. It's not really in the form of like checkboxes per se, but I thought it was really great because it calls out a lot of issues in security that people suddenly think that if I get this certification or if I adopt this framework that we're suddenly secure, and it's not necessarily the case. As the call out in security policy and compliance here for what Lenny says, jump into a full-blown adoption of frameworks such as ISO 27001, 27002 before you're ready. Because quite frankly, a lot of organizations aren't ready, and they really should take the time to get ready before they do that.
You know what I find interesting too, and it's one of my points on logging. Delete logs because they get too big to read.
Yeah,
or just too big in general. Like I was, messing around with stuff lately, and it's like, well, is it because I'm out of disk space, or are the logs too big to parse? And so, you just redirect or pipe dev null right into your log files to fix the problem. And you might have just deleted a whole bunch of evidence that could have led to discovering a compromise, for example. So,
and you would hope that with the price of disk space being as small as it is today, especially if you push things out to like tape through Amazon, right? Like the cold storage, you really shouldn't be deleting logs because they get too big to read. You should be making sure that you are effectively parsing those logs for the data that you actually need, which brings us full circle to the beginning of this episode, which is only collect the data that you really need to be collecting. If you collect too much more, you're going to find that you get a lot of noise in that signal. So with that, I want to wrap up this week. Thank you everyone for joining us this week for another episode of Application Security Weekly. Remember to git, commit, and stay classy.